This video compares and contrasts distance time graphs and velocity time graphs. So to be able to understand the foundations of this really, we've got to know the difference between speed and velocity for a start. And if you remember that speed is a scalar, velocity is a vector, and it's speed in a given direction. So this first graph that we have here is our distance time graph, distance on our y-axis, time on our x-axis. And we've got to be able to look at that and label it and understand what's happening. So we can see this line here. We've got a nice gradient there. All right, so we've got a nice constant speed. So this here shows we've got a constant speed. The orange line is a steeper gradient. Right, so we've got a constant speed as well, but it's going faster. The green line here, this curved line, is showing that we're speeding up, we're accelerating. The flat part of our distance time graph tells us that our distance remains the same, but the time is going on. So at that point there, this vehicle, this object here, is stationary. And what we have here, again, it's a flat line. We've got a constant speed going down. This compared to this one is not as steep, this one is steeper, so it's going faster. And it's going back to the origin. That there distance there would be 0. So that's the story behind the distance time graph. What you might be asked to do, however, is to work out speed. If you remember that speed is distance over time, which you may also see it written down as v over s over t as an equation. So if I want to work out the speed of the object is travelling here at section A, and section A is to this point here. So our distance that we're travelling here is going to be 100 metres, and we divide that by the time it takes to travel 100 metres, which is 10 seconds, which is equal to 10 metres per second. So that is distance time graphs. On a velocity time graph, you can see here these two graphs look incredibly similar, but we've really got to highlight this here, this velocity, this speed here, because it makes this graph appear a little bit different. This line here on the distance time graph, remember, was when we're going at a constant speed. This one here is going at constant acceleration. Right, so we've got constant steady acceleration here. This line here, this green line again, means that the acceleration is increasing. So that's the difference there. That there is constant speed. This here is a steady acceleration, a constant acceleration. The plateau bit here, you can see the velocity is 100 meters per second and the time is going on. So that there is constant speed. All right, so that there is going at constant speed. This is accelerating. This is constant speed. And if it was stationary, remember on a distance time graph, that is stationary. A stationary object, that line would be on the bottom there. So that's comparing the two graphs. Now, what you might be asked to do is to work out the distance travelled by this object in this velocity time graph. So again, to do this, we've got to split it up into sections. All right, so you want to make triangles and squares and rectangles to be able to do this. And basically, to work out the distance travelled, it's the total area underneath the line of the graph here. So all of this, that is the distance travelled. So how do we work that out? Well, very simply, all right, it's the area of the shape underneath it. So the area of this triangle here for section A still, that's section A, that's section B, and we've got C here. Section A will be half times the base times the height. That's the area of a triangle. Base times height for section B. And again, it's half times base times height for section C. So section A is going to be half times the base, which is going to be 10, times the height, which is going to be 100. So half times 10 is also going to be 5. 5 times 100, we're going to have 500 metres. So section A, it travelled 500 metres. B, the time here from here to here is just 10. And we've got 100 there still. So it's 100 times 10. So that's going to be 1,000 metres. And let's say here, if we had it, if this was drawn to scale, this bit here is going to be 21. So it's going to be half times the base, which is 1, times the height, which is going to be 50. And then if we add it all together, that's going to be 1,550 metres. So that's how we work out the distance travelled underneath a velocity time graph. So I hope that helps you to be able to compare a distance time graph and a velocity time graph. Good luck.